Euler published the solution to the problem of the 7 bridges of Königsberg in a paper, and this is his sketch of the bridges of Königsberg in the paper. Notice that he represented each land area by a single letter A, B, C and D. That was his way of saying that it didn't matter what the shape of the land region is or what its size is. All that mattered is that there were these 4 land regions A, B, C and D. And between A and B there were 2 bridges. This is the first and this is the second. Similarly, between A and C there were 2 bridges, and so on. In his own words from the paper, I use the capital letters A, B, C and D for each of the land areas separated by the river, and if a traveler goes from A to B, crossing bridge little a or little b, then I write this as A followed by B, where the first letter refers to the area the traveler is leaving from and the second letter refers to the area he arrives at after crossing the bridge. So, if someone walked across a bridge from land area A to land area B, that would be represented by a pair, an ordered pair, A followed by B. And since there were 2 bridges between land regions A and B, he distinguished them by using small letters little a and little b. So this is how he was modeling the given problem as a graph. So today we would represent this same map using a diagram like this. There are 4 vertices, we also call them nodes A, B, C and D, corresponding to the 4 land regions that he had on his map. And the vertices are connected by lines that are called edges. So the 2 edges connecting vertices A and B represent the 2 bridges that connect those 2 land regions in the map. Since one can walk across a bridge in either direction, the edges don't have any directions on them. So the edge from C to D, shown here, the edge from C to D is the same as the edge from D to C. This diagram of vertices and edges is called a graph, and this is an undirected graph because the edges don't have any directions on them. If they were one-way streets, we would have put arrows on them indicating the allowed direction of movement across them. Then we would have called this a directed graph. Now 2 vertices are said to be adjacent if there is an edge directly linking them. So vertices C and D, for example, are adjacent because there is an edge directly going from C to D or D to C. On the other hand, vertices B and C are not adjacent because there is no edge directly linking them. A path in a graph is a sequence of adjacent vertices. So CDB is a path. Why? Because C and D are adjacent and D and B are adjacent. On the other hand, DBC is not a path because there is no edge between B and C. A cycle in a graph is just a path which ends at the same vertex from where it started. So for example, CDB is a cycle. ADBA is also a cycle. But CDBC is not a cycle because it's not a valid path. Now, Euler himself did not use such a diagram, nor did he use terminology like a graph or a vertex or an edge. The terminology was developed much later. In fact, the very first textbook on graph theory was written in 1936, 200 years after the story that we are looking at. It was written by Koenig, whose name has a coincidental resemblance with the name of the city of Königsberg.